Today we're going to do two problems together. We're going to start with the first one. The first one is m squared plus 18m plus 81 equals 0. So we know we need to start by factoring, and then factoring starts with a puzzle. We're looking for two numbers that multiply to make 81 and which add to make 18. Well, the first thing that comes to mind for 81 is 9 times 9, and conveniently 9 plus 9 is 18, so that's our split for the middle term. We're going to keep the first term. We're going to split 18m into plus 9m and plus 9m. Notice we're using an m, not an x, because there's no x in this problem. And we're going to keep the last term of plus 81 equals 0. Then we're going to use our parentheses, and we're going to create two binomials which are being added together, the sum of two binomials, and we're going to do our two GCFs. So m squared and 9m both have an m in common. M needs to be multiplied by another m on the top and by an 9 on the bottom. So we have a GCF of m and a binomial factor of m plus 9. Looking at the second pair, we have 9m and 81. Well, those are both divisible by 9, and would need to be multiplied by an m on the top and another 9 on the bottom. So we have a GCF of positive 9 and a binomial factor of m plus 9, which conveniently matches the binomial factor in the first half of the problem. So we can factor out the m plus 9, and that leaves behind a second factor of m plus 9 equals 0. So each of these factors needs to be set equal to 0, but we notice that they're actually the same. So I don't really need to do this out twice. It's going to give just one answer. We're going to subtract 9 from each side, and m equals negative 9. That's our only answer in this problem. Remember back to when we were solving by graphing, that can happen. It's possible for a parabola to touch the x-axis only at its vertex. And when that happens, you only get one x-intercept, which means there's only one value for x that makes y equal to 0. This graph would basically look like this, where it's touching the x-axis at negative 9, 0. All right, let's take a look at this problem together. Notice this problem only has two terms. Whenever it only has two terms, we need to ask ourselves, is the middle term missing, or do I need to take out a GCF? Sometimes the answer to that is both. So let's start with the GCF, because when that's possible, that is always the first thing we should do. Notice 5j squared and negative 20 are both divisible by 5, so we'll start there. When I factor a 5 out of both of the terms, I'm left with j squared minus 4. So then I ask myself again, is there another GCF, or is the middle term missing? Well, notice the first term is a square, and the second term has no variable. That's the situation where the middle term is missing. So I need to put in that plus 0j so that I'll be able to split the middle term. The 5 on the outside is just going to stay there as I do all of my factoring. So we're looking for two numbers that multiply to make negative 4, because negative 4 times 1 is negative 4, and which add to make 0. Well, if they're going to add to make 0, they need to be the same number but with opposite signs. So that would be 2 and negative 2. So I'm splitting the middle term to give me j squared plus 2j minus 2j minus 4. And then we're going to go ahead and make the sum of two binomials and look at our GCFs. Well, j squared and 2j are both divisible by j and need a j and a 2 to multiply back to their original parts. So outside the brackets we have the 5, and now inside we have a GCF of j and a binomial factor of j plus 2. Then we look at the second two, noticing that the first term is negative, so our GCF will be negative. They're both divisible by 2, and the top needs to be multiplied by j, whereas the bottom needs to be multiplied by a positive 2. So we have a GCF of negative 2 and a binomial factor of j plus 2, which is good because that matches the first binomial. So we won't need the big brackets anymore. We have 5 times j plus 2 times j minus 2 equals 0. Well, this time we have 3 factors. One factor is 5, but 5 never equals 0, so that's not going to generate a solution. J plus 2 could equal 0. If we subtract 2 from both sides, we find j could be negative 2. And j minus 2 could equal 0. So we add 2 to both sides, and j can equal positive 2. So there are 2 solutions to this problem. All right, if you look at the rest of the sheet, you'll see that I've given you hints on 3 of the questions and left 1 question for you to figure out what's going on your own. So today you're going to do quite a bit of work independently and then take a picture of your work and submit it in the Google Classroom.